in our section 2 here, we'll be talking about inequalities. So first off, an inequality is basically just anything that uses the less than, the greater than, the less than and or equal to, and the greater than and or equal to signs. That's basically the entire idea behind an inequality. You'll see the words for inequalities kind of all around, especially if you talk about driving. Because if you talk about a maximum speed limit, it means technically that's the highest that you should ever be going, or you're going to get a ticket. All right. First example, we're going to use this graph to help explain the first bit of our stuff. So using this graph, we're going to write the solution set for the quadratic inequality. So we're going to say, where does x squared minus x minus 2, where is it greater than 0? Well, we can actually just look straight at our graph here and see it's greater than 0. So greater than our x-axis, because technically both of these sides are y. So it's y equals x squared minus x minus 2 and y equals 0. So that x-axis, since we're talking about where is it greater than 0, we're talking about this entire part here and this entire part here. The way that we would say that is that it's all of our x's when our x's are less than -1 and when our x's are greater than +2. Of course, it's still all the values that are, so we say that it's all of real numbers, because it could be that -1.11111, and as whether I've mentioned or you guys mentioned, technically there's an infinite amount of numbers in between each of these numbers. So yeah. Where are we getting that -1 and 2 from? Well, we can read it, but at the same time, if we were to factor this, it would be an x subtract 2 and an x plus 1, which means our two x-intercepts would be +2 and -1, which is exactly what they are. So these two intervals, when x is less than -1 and x is greater than 2, is when our entire parabola is greater than 0. If we ask where is it greater than and or equal to 0, all that's going to do is change what our inequality sign is going to be. It's going to be all our x's that are less than and or equal to -1 and -1. And our x's are greater than or equal to +2. Once again, all real numbers. If we are asking, so I'm just going to erase that. If we're asking where is x squared minus x minus 2 less than 0, let's talk about where is it below the x-axis. Well, it's below the x-axis in this entire part right here. You'll notice that, yes, these questions look very similar to our piecewise. And it is. Because it's still just talking about that greater than or equal to, because we had done those inequalities when we had done our absolute. So where is it less than 0? Well, it's in between -1 and 2. So to say in between -1 and 2, we say -1 is less than x, which is less than +2. X and elements of real numbers. If we further ask where is it less than or equal to 0, the only thing that's going to change is what our inequality is. -1 is less than and or equal to x, which is less than and or equal to 2. Just throwing this one in. X squared minus x minus 2 equals 0. Oh, that's nice. Where is it equal to 0? Where is it actually equal to our x-axis? No, it's right there and right there. So we say it's actually at -1 and 2. Sorry, didn't need that extra negative. There's a squirrely bracket. There's our brace, which didn't want to turn out. All right. Now we go further and we don't actually have the graph, we can still do it. Because this question is asking, where is x squared minus 10x plus 16 less than or equal to 0? Well, it's asking where is it less than or equal to our x-axis. So if we can find out what our x-intercepts are, we can find out what it actually is. So the first thing we want to do is we want to actually factor. So it's a simple trinomial, so we can just do our two brackets. Product of 16 and a sum of -10. Hopefully in your heads you're saying it's -8 and -2, which means 2 times that it hits our x-axis would be at +2 and +8. Now you don't have to do this, you certainly can. Actually, I want to do the case analysis first and then I'll show you graphically. So the case or sign analysis, yes, we're going to bring back that sign analysis just like we had done with our reciprocals. We're just going to do it in a different fashion. The first thing we want to do is we want to put those 2 zeros across the top of our chart. I've left space on the left, in the middle, and on the right. Then all I'm going to do is put these 2 factors, so the x minus 8 and the x minus 2, down the left-hand side. Notice how I don't have that 1 because we're not talking about the reciprocals, we're just talking about where is this less than 0. So the first thing we do is identify our zeros, so x minus 8 equals 0 there. If I plug any number that's less than 8, 7, negative 17 trillion, it's going to be negative in this area. Again, notice how I've put 1 to the left of the 2, at the 2, in between the 2 and 8. And if I put any number bigger than 8 in, it would be positive. In a similar fashion, x minus 2 equals 0 at 0. Anything less than 2, 0, negative 17 trillion, would be negative. Whereas any number that would be greater than 2 would be positive. Now we're going to do our sign analysis on it, because we have to ask this x minus 8 multiplied by that x minus 2. So we're multiplying these values. Negative multiplied by a negative is positive. A negative multiplied by 0 is 0. Notice how this is different than just our vertical asymptote because we're multiplying here. We're not dividing by that 0. A negative and a positive is negative. 0 multiplied by a positive, again, we're multiplying here, is 0. And a positive multiplied by a positive is positive. So the question here is asking, where is this parabola less than or equal to 0? We're talking about where is the product of x minus 8 and x minus 2, where is it less than or equal to 0? Well, I'm talking about in this entire area right here, in between 2 and 8. And the way that we notate that is that all of our x's are in between 2 and 8. If I further make the connection to what the graph would look like, I don't need to know exactly what my vertex is, but I can know that my x-intercepts would be 2 and 8. That would be the 2, that would be the 8. And since it's a positive parabola, would look something like this. So overall, the question is asking, where is the parabola less than or equal to 0, or less than or equal to the x-axis? Well, it's below it, in between here and here, which is between 2 and 8. If you see a question where it's not fully manipulated correctly, we're just going to manipulate correctly. Now, note here that we are not solving graphically. And I'll mention what this means as soon as we've finished with our question. So the first thing that we're going to do is we're going to get one side equal to 0, because it's going to be the easiest way for us to actually factor correctly. The first thing we're going to do is move our x squared and that 3x over. 0 would be less than x squared minus 3x. Make that actually look like a 3. Subtract 10. Now this one may not be the best to read, so what I would recommend is literally just switching it over. So x squared minus 3x minus 10. But since it's 0 is less than this, it's opening towards the parabola. We're going to have to still make sure that it's going to open towards the parabola. The reason that we're doing this is just so we can actually read it nicely. We're asking, where is this parabola greater than 0? Otherwise, we're saying, where is 0 less than the parabola? So it's just kind of not the easiest to read. So this is what I encourage you to do, is just put this parabola over on the left-hand side. Beyond that, then we're going to factor. So it will be x subtract 5 and x plus 2, which means that our two x-intercepts would be -2 and +5. We do our sign analysis. Notice how I do have it called case analysis as well, just because our textbook also uses the word case. They're the same thing, essentially. Put those two zeros across the top. X minus 5 and x plus 2 down the left-hand side. Let's see. I'm going to zoom through this one. So that's where it equals 0. That's where that one equals 0. Negative on the left, positive, positive, negative. Again, we're multiplying here. That's why we're not doing a vertical asymptote here. If it was 1 over this, then we'd be dealing with a different story. So if we had that reciprocal function. So our entire question now is asking, where is the parabola greater than 0? Well, it's talking about everything that would be positive. So it'll be two separate parts. So when our x's are less than -2, and when our x's are greater than 5. So that would be that. I want to just make the note of what this is fully meaning. So we're not solving this graphically because technically, if we were, so we don't have to write this down. But what this really means is saying we have two equations. Y equals -x squared plus 3x, and y equals -10. So this one, I could factor out a negative x and be left with x minus 3. I'm just doing this just so I can graph it a little bit nicer. So I'm going to graph this one in green, and I'll graph this one in blue. So first off, we'd have two x-intercepts. We'd have 0 and positive 3. Oh, sorry, green. Because that would negative x would equal 0 at 0, and x minus 3 would equal 0 at 3. This would be a negative parabola, so we'd have something that would look something to the degree of this. And then we'd have negative 10. Well, y equals negative 10. We'll say negative 10 is about right there. The original question is just saying, where is this parabola less than negative 10? Well, it's less than negative 10 in this section and in this section. And by doing it graphically, what we're saying is, what are these 2 points? Well, we actually did solve them. They're negative 2 and positive 5. So I'm not saying you can't do this. I'm just saying this is another way this is probably the preferred way, because we already did our factoring. We found out exactly where these would be. We don't have to worry about doing all the graphing for 2 separate things. And all of this skill stuff is being brought back so we're not forgetting the individual skills that we've learned so far. All right, last question. It's actually not that bad. Yes, it should be example number 4. You are not blind, and I did forget the number there. All right, the length of a rectangle is 3 meters longer than its width. Area of the rectangle is less than 55 meters squared. What are the possible dimensions of the rectangle to the nearest tenth of a meter? Well, we have a rectangle. What we're going to do is, we're just like in the first section, we're going to have to do some kind of let statement. We're going to have to say that we'll say that W equals the width. So our width would be here. If the length is 3 meters longer than the width, 3 meters greater, what we can do is say that it's W plus 3. And that would be the area. Or sorry, now we're going to solve for what the area is. Well, the area of a rectangle is just length times width. So W plus 3, that's not an absolute. W plus 3, round bracket, multiplied by W. The area, which will be this, is less than 55 meters squared. So it's going to be less than 55. So here's what we're doing. First things first, we're going to distribute. So we have a W squared plus 3W. And to make our lives easier, in one step, we're going to also subtract that 55 over in that first. And it would be less than 0. So again, notice how the question is completely changed by us doing this. The good news is we just have to find out, where is this parabola less than 0. The bad news is we can't factor this, because there's no way that we're going to get a product of 55 and a sum of 3. Especially since the factors of 55 are just 1 and 55 or 5 and 11. Which brings me to the reason why we are doing this question. And it's a beautiful song of the fact that, technically it's X, but we'll call it W now. W equals negative B plus or minus the square root of B squared minus 4AC. C all over 2A. Because we can't forget those skills. We're not going to forget those skills. So we'd have -3, adding and subtracting, square root. Let's see, 3 squared is 9. We can all type that all into our calculator. So let's see, that'll be 9 subtracting 4 times 1 by -55. Please make sure you can type that into your calculator and you get 229. Going to the decimal for it, let's say -3. If we add the square root, now we're not 229. Let's see, 2 and 2 is 4 plus 9. I'm going to bet that 229 is very relatively prime. We're not going to simplify this. Normally we would, absolutely. Well, let's see, is 229 completely prime? I just did a nice quick calc or a quick Google. Yes, 229 is absolutely prime. So we're not going to be able to do 229 as 2 times 3 times 7. No, it's just not going to work. So -3, if we add that, square root of 229 divided by 2, we're going to get, let's go to the nearest 10th, 6.1. And if we were to subtract it, we get -9.1. Hopefully, you know, one of these answers doesn't work, and it's a 6.1. I'm just joking, come on. I have to have a little bit of fun while doing videos. No, we can't have a negative width, so 6.1 would have to be the only option. Now to put into context, we're not gonna do a sign analysis on this one either, just because, well, we don't actually have to. But we do have to understand what the context of the question is. So it does tell us exactly what our x-intercepts would be for this parabola. It would be -9.1 and +6.1. The parabola, I'll just make it go further down because I know that my y-intercept would be -55. That's not important. But the sketch of the graph absolutely would be important. We're asking, where is the parabola less than 0? Well, it's less than 0 all in, actually, I'm going to put that in red just so you can see it better, in this entire area here. But the problem is, we can't have any of these values here. We can't have any of these values because our width can't be negative. We would only be able to start counting from 0. So when the width is 0 all the way to 6.1. So the possible answers to the nearest 10th, possible dimensions, is that our width would have to be between 0 and 6.1. Now, the width can't actually be 0, though. So our width would have to be between 0, so it can't be equal to 0, and to the nearest 10th, it also would have to be still that less than 6.1 because it was, what, 6.06 or something like that? Yeah. So it would have to be between 0 and 6.1, but we wouldn't be able to include any of them. So it's just a kind of a fun word problem just to get us into the actual applications of what this really is. I know that some of you will never deal with it. Same time, you know that I think that math is fun because I know that I'm a nerd. All right, take a shot, have some fun.